Project title: Encryption Based Secure Distributed Data Storage. Presented by Sai Ganesh, 10 UECS 0054, Ranjit Kumar R, registration number 10 UECS 0052, internal guide P. Shubha. Abstract: maintaining a large number of files from the owner to proxy servers. Proxy servers can convert encrypted files for the file owners to encrypt files for the receiver without the necessity of knowing the contents of the original files. The original files will be removed by the owners for the sake of space efficiency. In this paper, we propose two identity-based distributed data storage standard models, where one query that receivers can only access one of the file owners instead of all files. In other words, an access permission, re-encryption key, bound not only the identity of the receiver but also the files. The access permission can be decided by the owner instead of the trusted party. Furthermore, our schemas are secure against the collusion attacks. Existing system. The main algorithm uses an existing system's data encryption standards. In DES schemas, a user can outsource his encrypted files to untrusted proxy servers. Proxy servers can perform some functions on the outsourced ciphertext without knowing anything about the original files. Unfortunately, the technique has not been employed extensively. The main reason lies in that users are especially concerned on the conflicting, integrity, and query of the outsourced files, as cloud computing is a lot more complicated than the local data storage schemas. Data encryption standards. Description of the algorithm. The DES algorithm turns a 64-bit message blocks into a 64-bit cipher block. If each 64-bit block is encrypted individually, then the mode of encryption is called electronic code book, ECB mode. Key size used 56-bit, block size 64-bit, structure balance physical network, round 16. DES now considered insecure because brutal force attack is possible. Disadvantages of existing system. Users are especially concerned with the conflicting, integrity, and query of the outsourced files, as cloud computing is a lot more complicated than the local data storage systems, as the cloud is managed by untrusted third party. Proposed system. Algorithm used: AES, Advanced Encryption Standards. We propose two identity secure distributed data storage schema standard model, where one query the receiver can only access one of the owner's file instead of all files. In other words, the access permission is bound not only to the identity of the receiver but also the file. The access permission can be decided by the file owner instead of trusted party. Our schemas are secure against collision attack. AES algorithm description. Based on the design principle known as substitution permutation network, and is fast in both software and hardware. Unlike its predecessors, DES AES does not use a physical network. Key size 128, 192 or 256 bits. Block size 128 bits. Structure substitution permutation networks around 10, 12 or 14. The number of cycles of repetitions are as follows: 10 cycles of repetition for 128 bit keys, 12 cycles of repetition for 192 bit keys, 14 cycles of repetition for 256 bit keys. AES operates on 4x4 column major order matrix of bytes. Advantages of proposed system. It has two schemas of security. The first schema is CPA secure. The second schema achieves CCA security. To the best of our knowledge, is the first IBSDDS schemas where an access permission is made by the owner for an exact file, and collision attack can be protected in the standard mode. Comparison between two algorithms, the existing and the proposed. Key length 56 in DES, 128, 192 or 256 in AES. Block size 64 in DES and 128-bit in AES. Ciphertext, symmetric block cipher, DES algorithm. Symmetric block ciphers in AES algorithm. Security, proven inadequate in DES and considered secure in AES. Modules. Data owner. In this model, first the new data owner registers and then gets a valid login credential. After logging in, the data owner has the permission to upload their files in the cloud servers. The data owner encrypts his data and outsources the ciphertext to the proxy servers. The data owner sign-in page. The file upload area. File share and key sending to the receiver.